Okay. Hello, friends. This is Mr. Sarvesh Varjurkar. We are here for the session organized by Ballarpur Institute of Technology, Ballarpur, under AICT sponsored Prerna scheme for SC/ST students of Computer Science and IT department. Today is our session number 21, in which we are going to see about the database management system, and the topic for today's discussion is ER model and relational models in database management system. What is ER model? ER. ER stands for Entity Relationship Model. As the name suggests, as we know that this is the subject, say DBMS, unless and until you are having various relations, the things will not get passed, the things will not get in. The reason, there is a relation between every single data along with its own model, where we can move from in the, of course, first of all, we'll see about what is data, and then what is data model, and then accordingly we'll move forward. We'll say that we move from informal description of what user wants to. First of all, it say that it is a precise description of what we can be implemented in database. As the name suggests, database, that means a data, lot of data is stored in a particular memory or in a particular way, in which we have to manage that data according to the relations. We have to manage that all the data according to the relations. What is database? There are various steps of developing a database. First is requirement analysis. You can imagine a real life example. See, if you have a shelf, a bookshelf, where lot of books have been stored, lot of books, I can say around 100 plus books, that is a complete database. But it is not possible for a single human being to read and to use all the 100 books at a time. What he wants to use is, he first of all go with a particular analysis, that I want to read out some mythological books, I want to read out some technological books, I have to read out some novels, and so on. These are the various categories in which the books are distributed over there. In that distribution, in that database, there are various steps for developing such type of database. You know that if the user is that much genuine, he can definitely aware about the database, he can definitely partition all these books in various according to the requirement analysis. According, it may be in conceptual database design, it may be in logical database design, it may be a scheme refinement. Of course, physical database design can also be the part, and applications, and along with the security of the database. These are the various 6 steps are there in the developing of a database. First of all, we'll go with the conceptual design, ER model, which is used at this stage. What does that ER stands for? ER stands for E stands for entity, and R stands for relation in the enterprise. What information about these entities and relationship should we store in the database? What are the integrity constraints and or business rules that hold? We'll see. I have all the business rules with me, and the database scheme in the ER model can be represented pictorially called as ER diagram. Of course, the diagram is not enough unless and until we are showing the relationship schema between the entities in between that diagram, like this. ER model basics. See, if I want to store the data of all my employees, I have say around 100 employees, in which the categories are SSN, that is their number, their name, and their IoT. What it means, a real world object distinguishable from other objects, but an entity is described using a set of attributes. That whole set of attributes, each attribute is known as domain. For example, employee is having 3 different domain. One is SSN number, Then second is name, and third one is IoT. An entity set is a collection of similar entities. For example, all employees is a collection of similar entities. All entities in an entity set have same set of attributes. Set of attributes are like SSN, names, and IoT. Each entity set has a key within. What is that key? That key is a minimal set of attributes which uniquely identify an instance of entity. Many candidates choose one to be a primary key, and SSN versus name, that must be of course unique. Every single employee has his own unique identity, and with that unique identity he used to be identified. Same thing uh, when we are going to see in any entity diagram. It happens that that ER models can be, it works with the help of various relationship. Like some ER model basics, I can say again in the same part, that association among the two or more entities. For example, Atisho works in pharmacy department. Some employee name, uh, whose name is Atisho, works in this department. Employee name is Atisho, works in pharmacy department. There are various department. What is the relationship between them? That is collection of similar entities along with uh, an array relationship set are relates in n entity sets, even up to en, even e2 e3 up to en, whatever the number of entities are there. Each relationship in R involves entities like even small capital even up to small en, capital En, like this. Same entity could characterize should partition it in different relationship sets or in different roles in the same set. For example, if if, if in terms of employee all the SSN numbers are different for each and every employee, in real life world the names may be same but SSN number may not same. Of course, if I am going to deal with that particular part in terms of employees, who works in which department, and that departments are various departments, like one is pharmacy department, another is say medical department, another one is say engineering department, and so on. At the end, it also have to reports to subordinate, superior, and so on, like this. Like employees have to reports to subordinate or his supervisor, and employees is a separate entity which is having the relation between the SSN number and the name of the employees along with the IoTs as well. Identification. Key constraints. What are the key constraints? They consider works in an employee can work in many departments. Like a single employee can work in say various department, like he may work in pharmacy, he may work in medical, he may work in engineering, and whatever that thing. But a department can have many employees. A single department, it is not related to only one or two employees. No, it may be n number of employees can works in a particular department. Of course, which type of relation it is? It is many to many, like this. In this diagram I have tried to explain about various key constraints in the diagram, in the entity relationship model. In contrast, like each department has at most one manager according to the key constraints, or on managers. That arrow indicates that a gap that given in the department uniquely determines the manage relationship in which it appears. Say one employee, one department. It's into one to one type of thing. A single employee is dedicatedly working for a particular department. He is not a part and parcel of other departments. So on left hand side we'll say that it is the employee, and right hand side it is the part of departments, like this two I can say like oval shape diagrams are like, one is the this left side is the employee and right side is the department. Employee is one, but he can works in many departments. He can work in one department as well. So fine. Like this, I can say single employee, single department, single employee, two departments. This type of relationship is called as one to many. I hope you are getting. This type of relationship is called as one to many. Third one is third one is employee with the departments. Again, many employees can work in one department. Many employees can work in one department. That is fine. Yeah, we can see over here two different employees, say employee number 3 and employee number 5, are working in the same department, that is in department number 3. That type of relationship is called as many to one. And last is many to many. N number of employees can working in n number of departments. Like this, we can say that it is a many to many type of relationship. How it occurs? Unless and until it is logically correct, we cannot operate it in a particular database. Participation constraints, that's why I'm going to say it in another words. I can say, or I can summarize like the complete ER diagram is like ER model is represented by means of ER diagram, and any object, for example any entities, attributes on any entity relationship sets and attributes of the relationship set can be represented within with the I can say with the help of that ER diagram. Like every department entity must appear in its instance of the relationship works, and that have an employee, and every employee must be in the department. Both employees and department participate totally in works in, or of course in works in, like employee works in which department, and department manages by the manager along with the employees as well. The manager manages the department as well as the manager manages the employees. Let's say that like another example. See, if department and employees you are fine, but yes, if we are going to deal with the real life example, the I can say like imagine the example related to student, teacher, and projects, where entities are represented by means of I mean we have always used that rectangle part, that is the employees and departments that we have used in the rectangle part. Rectangles are named with the entity set they represent, and attributes are the oval shape, where attributes are the properties of entities, and attributes are represented by means of that ellipses. I can say that oval shape. Even every ellipse represents some attribute, one attribute, and directly connected to its entity. If the attributes are composite, then there are further divided into tree-like structure. Every node in the tree, every node is then connected to its attribute, and then that is composite attribute and represented by ellipses that are connected with an ellipse. That we see that where whatever the ellipse are defined over here, they all are nothing but the attributes of that entity. uh, there may be a relationship that we have say that the relationship are represented by diamond shaped box, where see that there is a relationship of employees with the department, those who are working. Working is a relationship between the employees and the department. Department works in employees, no, employees works in department, that's fine. Name of the relationship is like written inside the diamond box, and then all the entities participating in the relationship are connected in line, connected to it by a line itself. Then binary relationship and cardinality is like a relationship where two entities are participating is called a binary relationship, and cardinality is the number of instances of an entity from a relation that can be associated with the relation. Yeah, I can again going to explain this particular one-to-one relationship when only one instance of an entity is associated with the relationship. It is marked as 1:1, and the following and the image which reflects that only one instance of each entity should associated with the relationship. Look at the first diagram over here. I have already said that when left part is the employee and right part is the department, so it depicts one-to-one relationship. Lastly, one to many is like when more than one instance of an entity is associated with a relationship, it is marked as one to n, or one to many, one to m as well. The follow the this image, the second image, like one to many, the second image is represented with the that the only instance of entity of on the left and more than on one instance of the entity on the right can be associated with the relationship. It depicts one to many relationship. I can say it depicts one to many relationship. Third one is many to one. When when more than one instance of entity is associated, when more than one entity is associated with the relationship, it is marked as n:1. And this particular image number 3 reflects that it more than one instance of an entity on the left and only one instance of an entity on the right can be associated with the relationship. It depicts many to one relationship. And at last, I can say it's a many to many type of relationship where the image number 4, which reflects that more than one instance of an entity on the left, more than one instance of an entity on the left, and more than one instance of an entity on the right. It means many to many can be associated with the relationship. It depicts that many to many relationship will be possible in such a way over I have represented. Then possible number of constraints are like participation of constraints that I have already been said. There are two different types of constraints. One is total participation and another one is partial participation over here. That is total versus partial. I can say like total, it means that each entity is involved in the relationship. Each entity is involved in the relationship, and total participation is represented by double lines or dark lines, I can say. Partial participation, where no entities no, not where not all entities are involved in all the relationship in the relationship. There where partial participation is represented by single lines that we have represented over here. You can look at the diagram properly, where every department entity must appear in an instance of the relationship that works in, and every employee must be in the department. That's why we'll say that is a partial entity. But both employees and the department participate totally in the works in. Employee also use that entity, which is part, that is that diamond box, can say it is a works in, where it is totally in works in. Department participate totally in works in. What is weak entity? A weak entity can be identified uniquely only by considering the primary key of another entity, another owner entity, I can say. And owner entity is a set, and owner entity set and weak entity set must participate in one to many relationship set. Owner entity set and weak entity set must participate in one to many relationship set, where one owner many weak entities can be applicable. Weak entity set must have total participation in this identifying relation, which we have said that employees are dependents are having the policies, and employees are also having the policies. Employee is a separate entity, as we know. They are having the various attributes like SSN, names, and IoT. But but uh, uh, but that cost that depends on the policy is not directly linked with the employees. Cost of policy with for the employees is also been there, but the cost of policy, that means of relationship, cost of policy with the employees is like with the relationship for which is there in between the employees and the policy. And that p names and age are nothing but the dependents. Weak entity, yes, owner entity sets And weak entity set must participate in one to many relationship set where one owner, many weak entities, and where weak entities set must have total participation in this identifying relationship set. Of course, it is then identifying relationship set. Now we are completely working about the various hierarchies, like various types of relationship, like ISA is a where in short words I can say is a relationship. As in C++, attributes can be inherited. If we declare that A is a B, that means every A entity is also considered to be a B entity, where upwards it's generalization and down is specialization, I can say. The arrow which is up towards the upward is nothing but the generalization, and the down is specialization. Employee is a hourly employees. I can say it is a relationship between employee along with its various employees. If we declare A is a B, that every A entity, sorry, every A entity is also considered to be a B entity, where upwards is generalization and downwards is specialization, I can say. Constraint in is a relation, where overlap constraints, it can I can say like Joe be an hourly employees. Joe is an hourly employee as well as a contract employee entities. Yes, if it is yes, if it is absolutely correct in terms of that entity relationship diagram, will allow that particular way. If it is not, we are not able to allow. Second is covering constraint. Like does every employee's entity also have to be an hourly employees? Hourly employees or contract between the employees entity? It may be yes or no. Reason for using is a relationship is like to add descriptive attributes specific to its to a subclass and to identify entities that participate in a relationship. What is aggregation? That when we are going to use, when we have to a model, when we have to model a relationship that involving entity sets and a relationship set. Aggregation allows us to treat a relationship set as an entity set for a purpose of participation in other relationship. Like employee is monitors until and unless all this process may get executed. Like projects are sponsored, and it is sponsored by the department, or department also sponsor the project. Sponsors the department, or department sponsors the project. So aggregation method versus ternary relationship, that when monitors in last example that I have just now explained is a distinct relationship with a descriptive attribute. Also we can say that each sponsorship is monitored by an employee. What is the design choices? What are the various design, how to design a particular entity relationship diagram? Can explain it with the help of example. uh, where should a concept to be modeled as an entity or an attribute? Next is, should a concept be modeled by as an entity or a relationship? It is dealing with the relationship, or it is dealing with the attribute, or it is dealing with the by. If it is dealing with the attribute, say we can say that it may be a binary or ternary. It may be an aggregation. Which type of relationship between these two need to again identify? There are various constraints that we are always take care of. First is a lot of data semantics can be captured, but some constraints cannot be captured in diagram. So I can say, like in this these are the various issues. Like we can say that use of entity versus attributes, where the use of entities to set entity set or attribute depends on the structure of the real world. That enterprise that is the being that enterprise that is being model, and a semantic associated with its attribute. Of course, it leads to a mistake when the user use the primary key of an entity set as an attribute or another entity set. Instead he should use the relationship that to do so. And the primary attributes and are implicit in the relationship set, but we designate the relationship set as well. So that's why I have just now mentioned, like entity versus attribute is like depends upon the use, what we want to make of the address information and semantics of the data. If we have several addresses per employee, addresses must be an entity. If the structure is important, we can say that we want to retrieve employees in a given city, addresses must be modeled as an entity. Next one is use of entity set versus relationship set, or we'll go with the entity versus attribute first, and then uh, entity versus relationship. So again, I can say, like I can continue with the help of this works in does not allow an employee to work in the department for two or more periods, similar to the problem of waiting to record several addresses for an employee. If we say that we want to record the several values of the descriptive attributes for each instance of this relationship, which are accomplished by introducing new entity set duration. Instead, we can say that if employee works in departments, for example, of course, it should carry the duration of that employee, from which date he works in that department to which date he is working in that department. So works in is also from the duration. Duration is again a bit different attribute, where we can say that duration is again a different relationship, where we can say that from which date to which date. That is the entity versus attribute type of. Second one is, as we have to move on, we have to see all the remaining different, I can say, designing issues. First we have covered, and now we are going to deal with the entity set versus relationship. What is that relationship? It is difficult to examine if an object can be best expressed by an entity set or I can say like a relationship set. To understand and determine, I can say like the right use, the user need to designate the relationship user need to designate the relationship set for describing an action that occurs in between the entities. For example, if I can say like diagram is okay if manager gets a separate discretionary budget for each department, that is fine. But what if manager gets a discretionary budget that covers all the managed department? No, then it is not up to the mark for the manager, it is not able to manage all the things for all the other departments as well as all the employees. No. So the d budget that's stored for each department managed by the manager, that is redundancy, that is fine. But misleading that suggests d budget associated with the department manager combination. Every department has his own manager. Every department has his own manager. All the managers can come together and they can set the budget. But if a manager who is going to set the budget for all the other department, that may not be accepted. This is a fixed problem, where I can say like SSN, they are the is a employee attributes for that employee. And then Ha. Then employee is a managers. I can say, of course, employee. One of the employee may be a manager, and manager manage the department. Of course, if he managed that particular department, he is able to give the budget or D budget of that department, or D budget. That D budget stands for department budget, I can say. This is all about that D budget, or I can say like entity versus relationship sets. Third one is binary versus ternary. where we can say that generally relationship between the generally the relationship that described in the databases are binary relationship. However, non-binary relationship can be represented by several binary relationship. It may be ternary, it may be whatever that thing. For example, we can create and represent a ternary relationship, that is parent that may relate to the child, to his father, and as well as his mother, of course. Same thing I have denoted over here. If each policy is owned by just one employee and each dependent is tied to covering the policy, of course, two dependents can cover the policy, and it is dependent is tied to the covering policy. First diagram is completely inaccurate. That completely inaccurate. What are the additional constraints that we need to do? We need to say that thus it is possible to represent a non-binary relationship by a set of distinct binary relationship. Non-binary relationship can be able to design, but with the help of distinct binary relationship. How? This is the better design. I can say like whatever the key constraints, total participation of policies in purchaser relationship, along with the nominees, or I can say like which word I have used, uh, dependent on the policy, like who are the dependent on that particular policy. If an employee you employee offers a policy, if an employee owns a policy, who are the relationship, who are the dependents on that thing. This should be help, or this should be denoted or detected with the help of a particular design called as relationship called as entity versus binary versus ternary type of relationship. Next is previous example, that is illustrated when the two binary relationship were better than one ternary relationship. And again, an example of this, another direction I can say, a ternary relationship that can contrast the relates and that can contrast the relates entity set, that is the parts, department, and suppliers, and has descriptive attribute quantity. So no combination of binary relationship is an adequate substitute. So can apply PS, can apply PC. The can apply, yes, one question on this particular topic. In entity relationship diagram or in entity relationship model, can apply relation is applicable in binary, is inapplicable in question mark. Options are with you: binary, ternary, or I can say like ER model, or I can say relational model, and option number D is none of this. Answer is ternary. Answer is ternary, or more than say ternary is not like exactly ternary, but we can say that we can apply to any other thing. If it comes to any other thing, it may be binary, it may be ternary, it may be more than that, it may be n number of things, n binary I can say. And and deals with S, that does not imply that B has agreed to buy P from S. Unless and until that relationship and unless and until that relationship satisfied, how do we record the quantity? The question arises, how do we record the quantity? So we can say that the conceptual design that follows requirement analysis that yields a high level description of data that can be stored, and the cardinality ratio that becomes an effective measure in the placement of relationship attributes. So it is better to associate, to associate the attributes of one to one or one to many relationship sets with any participating entity sets. Instead of any relationship set, the decision of placing the specified attribute as a relationship or entity attribute should process the characteristics of the real world enterprise that is being, that is being modeled. Again, I'm going to give it the help of give explain it with the help of another example. I can say like if there is an entity which can be determined by the combination of participating entity sets, instead of determining it as a separate entity, such type of attribute must be associated with the many to many relationship sets. Thus, it requires the overall knowledge of each part that is involved in designing and modeling and that is involved in designing and modeling of an ER diagram. Next, the basic requirement is to analyze the real world enterprise and the connectivity of the entity or attributes with the others. In another word, can say summary of conceptual design in which the basic contains that are entity, relationship, and attributes. Some additional constructs are like weak entities, is a hierarchies, and an aggregation. There are many variations. Yes, many variations of ER diagrams are possible. Yes, true or false? The answer should be true. Next is several kinds of integrity constraints can be expressed in the ER model that key constraints, participation constraints, and overlap covering constraints for is a hierarchies. Some foreign key constraints are also implicit in the definition of relationship set. Some constraints, those who are notably functional dependencies that cannot be expressed in the ER model, and constraints really plays an important role in determining the best database design for an enterprise. ER design is a subjective. We can say that it is a subjective. There are often uh, many ways to model a given scenario, and analyzing alternatives can be tricky. So especially for a large enterprise, we can say that common choices, those who are include, are like entity versus attribute, entity versus relationship, binary, or an array. An array, I mean any different number which is more than binary relationship, whether or not to use is a hierarchies, and whether or not to use aggregation. Ensuring good database design, that resulting relational scheme should be analyzed and refined further. So FD information and normalization techniques are especially useful. Now we'll come back to the next topic of today's discussion is relational model. What is the relational model? How that relational model covers, and what are the various constraints, along with what are the various schemas in that relational model? We'll see it in detail. Update operations and dealing with the constraints violation can also be the part that we are going to see it in this upcoming slides. The relational model of the database of the data is based on the concept of the relation, where the strength of the relational approach to data management that comes from the formal foundation which is provided by the theory of relation. We review the essential of the formal relation model in this upcoming slides, and there are various several important differences between formal model and practical model, as we will see. A relation is a mathematical concept based on the ideas of set, and the model was first proposed by Dr. EF Cord of IBM Research in the year 1970 in the following paper, where the relational model is a large shared data banks and communication of the ACM, which is in the June itself. Informal definitions are like informally a relation looks like a table of values, or relation typically contains a set of rows where the data elements in each row represent certain facts that correspond to the real world entity or relationship in the formal model, where rows are called tuples, and in each column has a header that gives an indication of the meaning of data items in the column. In which the informal model, the column header is also called as attribute name, or we will say that just as an attribute. We need to convert the conceptual model in the relational model, which can be implemented using any relational database management system languages like Oracle is a RDBMS language, that is that is relative management system, relational database management system, and like Oracle, SQL, MySQL, etc. So we'll see about relational model is what is relational model. Again, I can say relational model represents how the data is stored in relational database. How the relation is stored in relation database. In the given diagram, a relational database stores the data in the form of relations, that is in the table, that is in terms of table. As I have already said, it is a part of various tuples. Consider a relation between the student with attributes, say that SSN, we can say it as that roll number. SSN is nothing but a roll number, we can say, name, home phone, or phone number, address, and age, along with office phone number and that GPA. That is another table that we can definitely add it. One is, say, we'll say that there are the various attributes, and all the attributes are the properties of attributes are the properties that define a relationship. For example, roll number and name can be defined with the help of attributes like relational schema. A relational scheme represents the name of the relation with its attributes. For example, student, who is having the roll number, name, address, phone, age, is relation scheme for the student, schema for the students, related relation schema for the student. If a schema that has more than one relation, if a schema that has more than one relation is called as relational schema. What is tuple? Each row in a relation is known as a tuple. Each row, there are five different, sorry, one, two, three, four, five. Yes, five different row in a tuple. Five different rows in this table. So I can say that they all are nothing but the tuples. So Benjamin Bayer, Chung Cha Kim, Dick Davidson, Rohan Panchal, Barbara Manson. These are the five tuples, you can say, where the relation name is student. They are having various different roll numbers, they are having their different phone numbers, they are having their different addresses, they are also having office phone number, and all are of different ages as well. For example, if I go with one tuple of any of them, for example, say Rohan Panchal is having the roll number, say 489221100, who is having its phone number 3769821. Address is 265 Lark Lane, and the office phone which he is having is 7496492, and his age is 28, and his GPA is 3.93. What is that relational instance? Relational instance, that is a set of tuples of relations at a particular instance of a time, which is called as relational instance. The table one shows that the relational instance of the student at a particular time, it can change whenever there is an insertion, deletion, or updation in the database. Yes, if the database it is there, it is on the screen, it is fine that we can able to update that database at any amount of time. Can say at every amount of time, where whenever if it can be changed whenever there is an insertion or deletion or updation in the database. The degree, that is the number of attributes in the relation. There are one, 2, 3, 4, 5, 6, 7 different attributes in this table. So we can say that the degree of this is 7. Cardinality, now we'll come back to the cardinality. The just for a second. Yes. Cardinality is the number of tuples in a relation which is known as the cardinality, and the student relation defined over here is above has the cardinality. See 1, 2, 3, 4, 5. Cardinality is nothing but the number of tuples. So the column that represents a set of values in a particular attribute, and the column roll number is extracted from the relation of the students. So if there are null values, that null value is not known or unavailable, such value is called as null. Where, see, for example, say Dick, the student Dick does not having the phone number. I mean, he does not have the phone at his home, so that at that value is null. It is not represented by a blank space like phone of the student who is having roll number say 422112320 is null. It should not be blank over there. While designing the relation model, we will always keep in mind that we define some condition which must hold for the data that is present in the database called as constraints, and these constraints are checked before performing any operation. As we know that if it is a table, we are able to perform various operations over here. We can insert a new value into the table, we can delete a new value, we can delete a value which is already located or already stored in the table, and we can update the value in the database. If there is a violation in any of the constraints, operation will be fail. There are various constraints that we'll see in the upcoming slides. Firstly, we'll go with the definition like key of a relation. Again, when each row has a value of data item or set of items that uniquely identifies that row in a table, which is called as the key, and the student table which is having the roll number or SSN number is the key, where sometimes we say that row IDs are sequential numbers that are assigned as a keys to identify the rows in a table. If the row IDs or sequential numbers that are assigned as a keys to identify the rows in the table are called as artificial key or surrogate key. So the schema that our schema is nothing but description of a relationship that it is denoted by R of A1, A2, A3, A4 up to AN, and R is the name of the relationship, and the attribute of the relations are A1, A2, A3 up to AN. Again we'll go with another example, that is customer ID, customer name, addresses, phone number, etc. Customer is the relation name which is defined over four attributes, that is customer ID, customer name, addresses, and phone. Each attribute has a domain or a set of valid values. For example, the domain of customer ID is of 6-digit number in the given example over there. The tuple is an ordered set of values which are enclosed in an angled bracket where each value is derived from an appropriate domain. A row is a customer relation is a four tuple and would consist of four values. For example, say 632895 is the roll number, which is a tuple which is ordered in a name of John Smith, who is having the address 101 Main Saint Atlanta GA 30332 404 894 2000. This is called a four tuple as it has four different values. A tuple row, a tuple is nothing but a row as we have just now discussed in the customer relation, where a relation is a set of such tuples, or I can say set of such rows. A domain which has a logical definition. For example, USA phone numbers are a set of 10-digit phone numbers valid in the US, valid in the United States. Like a domain that has all that also has a data type or a format defined for it, which is the USA phone numbers that may have a format of DDD bracket. First of all, it is in the bracket, then DDD or the digit, 3-digit dash 4-digit. It is partitioned into 3-digit as a code first, then 3-digit dash 4-digit, where each D is a decimal digit. Dates also have various formats such as year, month, and date. Formatted as year can represent it with 4 digits. Months can represent with 2 digits. Dates also can represent with 2 digits. The attribute that name designates the role played by a domain in a relation. We can say that it is used to interpret the meaning of the data elements corresponding to the attributes. For example, the domain name may be used to define two attributes named invoice date and payment date with different meanings. The relation state that is a subset of Cartesian product of the domains as it attributes, and each domain Each domain that contains a set of all possible values the attribute can take. So attribute customer name is defined over the domain of the character string of maximum length say 25. What is that domain constraints? I'm very concern about that domain constraint. These are the attribute level constraints. I repeat, these are the attribute level constraints, and the attribute that can only take values which lies inside the domain range, whatever the range which is already been defined. If a constraint's age is greater than 0, is applied on the student relationship insert is applied on the student relationship, we can say that inserting negative value of the age will result in failure. We always know that age will not be negative at any of the case. Age should be a positive number. Same thing if you are saying that the number of United States, if you have not entered it in that in that desired way, which is which is already been mentioned as a standard format. First bracket is of code, second three digits is of digits and decimal digits, and the rest is three digits that dash four digits. Then and only then it is accepted. Otherwise, it may not be accepted. It results in failure. Second one is if we are going to deal with that key integrity. So I can say key integrity where every relation in the database should have at least one set of attributes which defines a tuple uniquely. Those set of attributes are called as say roll number, those who are completely unique, names, or sorry, the student, those who are completely unique. That may be the key. So no two students can have same roll number. Of course not. Yes, date of birth may be same, age may be same, but no two students have same roll number. So a key that has two properties. One is it should be unique for all the tuples, and it cannot have null values. If that particular keys are does not having null value, it's very much easy for us to recognize them with the help of that keys along with the name. Same example in terms of that customer name is defined over the domain of the character strings of the maximum length say 25. Domain customer name is varchar say 25, and the role these strings play in the customer relation is that of the name of the customer itself. Formal definition I can say like it's in terms of summary. uh, Given R A1 A2 up to AN, R which is a subset of domain A1 multiplied by domain A2 and so on up to say domain AN is a schema. R A1 A2 A3 A4 up to AN is a schema of the relationship R relation, and R is the name of the relation where A1 A2 A3 are up to AN are the nodes of the relation, and small r capital R is a specific state where of relation R, that is a set of tuples. We can say it as the rows. Then R of R is equal to T1 T2 up to Tn, where each Ti is an n tuple, and Ti V1 V2 V3 up to Vn, where each Vj element of domain say Aj. Yes. Uh, Again, the same example I can going to take it with the help of these slides. Along with that, I want to explain the characteristics of the relations. Uh, I can say like huh, I can say like if the branch code of a particular student, say computer science is the branch code for CS. Sorry, the branch code for computer science is CS. Branch code for information technology is IT, communication engineering is ECE, and civil engineering is CV. So branch code of the student can only take the values which are present in the branch code of branch, which is called as referential integrity. So ordering of tuples in the relationship, that the tuples that are not considered to be order, even though they appear to be the part of the tabular form. Ordering of attributes in the schema are, and the values which within each tuple, we will also consider that attributes in R, that is A1 R of A1 A2 A3 up to AN, and all these values in T, which is less than or equal to, I can, which is equal to v1 v2 v3 up to vn, that to be order. However, a more general alternative definition of relation does not require this type of ordering. uh, with the help of same as previous figure, but a different order of tuples. Order of tuples say like the first is name, then the roll number, then the home phone number, then address, then office age and age. Sorry, office phone number, age and GPA. The relationship of this the relation student in this figure is with a different order of tuples. See, the order of tuples in the previous table, the Rohan Panchal was at number 4, Benjamin Bayer at number 1, and along with I have simply changed the order of the tuples. That is fine. So values in a tuple are like all the values to be considered atomic, that is indivisible, and each value in a tuple must be from the domain of the attribute for that particular column. If a tuple T v1 v2 up to vn is a tuple row in the relation state R of R a1 a2 a3 up to an, then each vi must be a value from the domain say ai. A spatial null value is used to represent the values that are unknown or inapplicable to the certain tuples. Notation is another property, another characteristics. We refer to this component values of a tuple T by T of AI or T of T multiplied by AI, T dot AI. I can say like this is the value VI of the attribute AI for the tuple T. Similarly, say T AU AV up to AW refers to the subtuple of the T containing the values of attributes AU AV up to AW respectively in the T. Where some anomalies are there, that an anomaly is an irregularity or something which deviates from the expected normal state. When designing database, we identify three types of anomalies. First is insert, second one is update, and third one is delete. Whatever the things that we are going to update, delete or insert in the particular table is deals with that anomalies. Insertion anomaly is referencing relation. We cannot insert a row in referencing relation if referencing attribute value is not present in reference attribute value. For example, insertion of a student with branch code ME in a student relation will result in error because ME is not present in branch code. Since we have said that we have already four different branch code: CV for civil, IT for IT, CS for CSE, that is computer science, and ECE for electronics and communication engineering. There is no branch code which is present in terms of ME. So in that case, deletion or updation anomaly is reference to the relation. We can then delete or update a row. Reference relation, if value of reference attribute is used in value of referencing attribute. For example, if we try to delete a tuple from branch having branch code CS, it will result in error because CS referenced by branch code of the student. But if we try to delete the row from the branch with branch code says CV, it will be deleted as the value is not being used by the referencing relation. It can be handled by the various methods like on delete cascade and on update cascade. So relation integrity constraints will deal with that first. That constraints and conditions that must hold on all the valid relation states, where there are three main type of constraints. One is key constraint that I have just now explained, entity integrity constraints, and referential integrity constraints. Another implicit constraint is the domain constraint, where every value is a tuple that must be from the domain of its attribute. It could be null or if allowed for that attribute as well. So yes, super key of R. Firstly, we'll go with the key constraints, where it is a set of attributes, say super key sk or R with the relation with the following condition. Say no two tuples in any valid relation state, that is R of R, will have the same value for sk. Any set of attributes that allows us to identify unique row tuples any set of attributes that allows us to identify unit rows or tuples in a given relationship in a given relation are known as super keys. So out of these super keys we can always choose a proper subset among these which can be used as a primary key. Such keys are also known as candidate keys. If there is a combination of two or more attributes which is being used in a primary key, then we can call it as a composite key. A minimal super key, that is a key which is super key k, such that the removal of any attribute from k, that is from any key k, that results in the set of attributes, that is not a super key. It does not possess the super key, or it is nothing but the uniqueness property. Another example I can say, like, consider the CAR relation schema. Stage, serial number, car, that is I can say like car state which is having the register number along with the serial number along with make, model, year, and so on. Two keys, that means which state it is, from what is the registration number of that car. Along with key 2, we can identify it with the help of serial number as well. So both are also the super keys of the car. With that super keys we are definitely identified by whose car it is, what is the name of the car, from which state it registered, what is the serial number, what is the model, what is the year of registration, and so on, so on, so on. In general, any key is a super key, but any super key is not a key. I repeat, any key is a super key, but not any super key is a key. So any set of attributes that includes a key is a super key. A minimal super key is also a key. In a relationship that has candidate keys, or one is to choose an arbitrarily to be the primary key. So the primary key attributes are underlined, and over here I have underlined serial number. So with that license number, say these are the various tuples, say if, six different tuples: Texas, Florida, New York, California, and Texas RSK. These are the license number with the engine serial number. That serial number may be the key, and make uh, I mean the owner or developer of that car, which model it is, and which year it has been registered. So relational database schema is like a set of yes relation schemas that belongs to the same database, and database schema S is equal to R1 up to Rn. Same example, exactly like the car or the student. I'm going to with the help of this company database schema, where employee, department locations, projects, and works on, and dependents. So this is all about your entity integrity, referential integrity, and displaying the relationship database schema for the session. Other types of constraints are always there, but we'll cover all the remaining one in the upcoming slides, where we also have to deal with various languages, like various queries like SQL, Oracle, and so on. Uh, so in the upcoming video, I'm going to explain you about other types of constraints along with SQL, Oracle, and various models in the constraints. So thank you for your patience hearing. Over to you, Neeraj.
Yes, sir. Thank you. Thank you so much.
Yes.